So let's do some more simple examples of structural formulas. Let's start out with another one, methane, CH4. So this is a molecular or chemical formula. It tells me nothing about the structure. In this formula, I know that I have one carbon atom from group 4. That will give me 4 valence shell electrons. And I have hydrogens from group 1A. Each hydrogen will give me 1 valence shell electron. So that's a total of 4. So I have a total of 8 valence shell electrons that I must distribute around my structure. Typically in some of these formulas, what you're going to see is the first atom written is going to be your central atom, but not always. Carbon does love to be the central atom. Hydrogen can never be the central atom because it can only ever form one bond. So I'm going to draw my skeletal structure. Carbon will be central. I'll draw 4 dashed lines representing shared pairs of electrons, and then I'll attach my hydrogens because I have 4 things to attach. So each of these dashed lines represents 2 electrons, 2, 4, 6, 8. I've used up 8 of my valence shell electrons. That's all of them. My hydrogens have their duets. Remember, hydrogens don't get an octet of electrons. They get a duet. They are complete. And then my carbon atom has 2, 4, 6, 8. It has its octet. And this structural formula for methane is complete. And this is a typical bonding pattern of carbon. A typical bonding pattern that you see for carbon. 4 single bonds, and remember the typical bonding pattern for hydrogen that's non-charged is 1 single bond. Let's try another one. Let's do ammonia, NH3. So again, this is a chemical or molecular formula. It tells me nothing about structure. Hydrogen can never be the central atom. We have a nitrogen that can be. Nitrogen is from group 5A, that's 5 valence shell electrons. We have 3 hydrogens with 1 valence shell electron each, that's 3. Serendipity that we've hit 8 again for this example. So we have 8 valence shell electrons that we must distribute about our structure. Nitrogen will be the central atom. So I'll attach 3 dashed lines. So I have a skeletal structure. I'll place my hydrogens on the outside. The hydrogens now have their duet. They're happy. We've used up a total of 6 of our electrons. We have 2 more remaining, but we only have 6 electrons around our nitrogen to complete the octet. I'll put a lone pair on that nitrogen, 2, 4, 6, 8, and we've used up that last pair of electrons. So that is the completed octet for nitrogen, the completed duets for hydrogen, and that is a typical bonding pattern of nitrogen. Nitrogen likes to have 3 single bonds and 1 lone pair.